Hello, and welcome to the 14th video lecture of Quantitative Analysis for Business Decisions QABD Semester 2 Module number 1. In today's video lecture, we are going to study about advantages and limitations of graphical representation of data. So we have seen a different graphical representation of data, also diagrammatical representation of data. But what are the advantages of this graphical representation of data? That is what we are going to study today. So let us see this one by one. Graphical representation of data gives a bird's eye view of the entire data at a glance. So what happens in this is entire data, what is there, what you have tabulated or what you have collected, that entire picture of that can be represented in a single graph itself. So it gives a overall view of the entire data that you have collected, an overall meaning to the data. So that is why graphical representation is generally used, and probably it is one of the most important advantage that graphical representation has. Also, graphical representation can easily be understood by common man. Even a layman who doesn't know anything about statistics can very easily understand a graphical representation of data. It is very colorful, interesting. A lot of graphics can be used in graphical representation of data. You can use bar diagram, line diagram, pie chart. Lot of different graphs can be used so that you can also draw interest and attention of any common man. And he can understand it very easily. So this is one more advantage of graphical representation of data. The third important advantage of graphical representation of data is that it makes comparative analysis of data very much easy, and hence your work becomes very productive. You can compare different items or different categories or different variables along each other, especially when you are using something like a bar graph, simple bar graph. It becomes very easy to compare, for example, last year's production in a factory versus this year's production in a factory. So or else income of a person, monthly income of a person and monthly expenditure of the same person. Comparison becomes very much easy, and hence your work becomes very productive. One more advantage of graphical representation of data is that it can be remembered for a longer period of time. As we all know that graphs, pictures, graphics are actually easily remembered, and they are remembered by for a very longer period of time when compared to just text, words, numbers. So such kind of thing. So remembering, that is, it is stored in the mind of the receiver for a longer time because of the graphics. And lastly, they assist in better decision making, as they usually represent the percentage. See, whether you are using graphical representation of data, diagrams, or you are using tabulation or simple textual data, the main reason why you are collecting data is that it should be easier for the management to take better decisions, better business decisions. So graphical representation helps in better decisions, especially because it compares values based upon percentage. That is why we see pie charts are being largely used in businesses. Also we see that percentage bar diagram or component bar diagram are also used in business decisions. So these are some of the advantages of graphical representation of data. Now let us see what are the limitations of graphical representation of data. These are the disadvantages that graphical representation brings along with itself. We know that we have a lot of advantages, but it comes with certain limitations also. So what are these limitations? Graphs are only visual aids. Graphs are only visual aids. They cannot be considered as an alternative to numerical data. The numerical data is your actual data that you have collected. So graphs give you an overall picture of the numerical data. They are not alternative, or they you cannot substitute the textual or the numerical data with graphs. If you compare graphs and the numerical data that you have collected with respect to accuracy, definitely the numerical data wins hands on. The numerical data is far more important compared to the visual data that you are presenting with respect to graphs. The next important disadvantage that we are going to study is about the requirement of time. uh, we need a lot of time to draw various graphs, represent it properly, give proper legends, headings, and then put it in a presentation. So this requires a lot of time and requires skills, especially in the work statistical tools, using statistical tools on computer like SPSS or even a Microsoft Excel if you're using. So creating of graphs requires a lot of time. The third disadvantage we are talking about is that graphs are not accurate and give only a rough idea of the data. It is connected somewhat to the first point itself, because the actual data is the numerical data that you have collected. So it only gives us this rough idea about the data, an approximate picture of what is happening, an overall aggregate of the picture. They cannot be used for further statistical analysis of the data, like numerical data which can be used for further statistical analysis. You can find out mean, median, mode, range, standard deviation, variance, correlation, regression. Lot of things can be done using numerical data. But when it comes to graphical representation or various graphs that are using, it is difficult to or in fact it is impossible to do any statistical analysis, and it cannot be used for any further statistical analysis. They defy secrecy. Next thing, that is, you cannot keep any point secret in graphical representation, as graphical representation gives a bird's eye view of the entire data, that is, in full data is shown in a picture or something. So anything, if certain points are there which you want to keep it as secret, you do not want your viewer or your audience to know about that particular point, then certain times it becomes difficult to hide these kind of things. So they defy secrecy. Nothing is kept secret, everything is kept in an open thing. Though you can change the graphs little bit, you can use it intelligently, so that these kind of hidden things which are there, you do not want to bring to the knowledge of your audience, then you can avoid such kind of things. But you need a lot of knowledge about using various graphs. They are sometimes misleading and can create a wrong impression about the data. Definitely, statistics, we all know that it has one of the major limitation is that statistics can be misleading, especially if it is used or if the data goes in the wrong hands and it is used for wrong reasons. It can be very much misleading. Similarly, graphical representation also can be misleading. They can create wrong impression in the minds of the audience about a particular data. So apart from the advantages and disadvantages of data, the next concept that we are going to study is the false baseline. It is also known as a kinked baseline or a kinked baseline. So what is a kink? uh, so generally, false baseline that is there, as we know, false means something that is not true, which is not actual. Base, the actual base that we are drawing, baseline, that is at the bottom. And line is a device relating to graphical presentation. It is used in graphical presentation. This line is used to break the continuity of y-axis when with the origin. We know that just for this, this is the x-axis and this is the y-axis, and this is the origin. Okay, so generally origin is 0. So 1 2 3 4 5 6, or maybe 100, 200, 300, 400, 500, 600, and so on. Here also 100, 200, 300, 400, 500, 600, and so on. So if you want to break the continuity, that is somewhere you want do not want to show certain line, so at that time a kinked baseline, kinked or a false baseline can be used. uh, how to use it we are seeing in the coming slides. If we maintain continuity of the line value of the origin, then a significant portion of the graph would go waste. For example, I'll show give you an example here so that you can understand. Suppose if the origin is 00 here. hmm, Now you are taking 5 different measurements of temperature in Fahrenheit of uh, patients in a hospital, and they are say 95, 96, 96, 9, temperatures, I'll note it down once more: 96, 97, 97, 98, 98, 99. So these are the 5 patients. I'll go through this again once more: 96, 97, 97, 98, 98, 99. So these are the 5 patients which with Fahrenheit degrees, that is body temperature in Fahrenheit. Now if you I ask you to plot it uh, on the graph, the first patient, patient number 1, patient number 2, patient number 3, 4 and 5 are here. Now you want to show temperature in degrees. Suppose 1 centimeter equal to 10 degrees you take, then it becomes 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So suppose 90, 100, your graph sheet, you are losing lot of space between 0 and 90, which is not utilized. That is what they are saying here: a significant portion of the graph would go waste. Significant means a big portion. So to avoid this, and also what will happen is, you suppose this is 90 and this is 100. So your graph will look like this: 96, 97, 97, 97, 98, 99. The variation that is there is not seen that much. Okay, but on the contrary, if you're using a false baseline, suppose something like this is 0, the false baseline is shown like this way, little bit kink, that is you are cutting the line there, 0, then you are starting with 95, 96, 97, 98, 99, 100. Then you can very easily see this: 96, 97, 97, 98, 99. So you are, what you are doing is, you can see very easily what is the difference or what is the changes that is happening. So this is one more advantage or objective why false baseline is used. False baseline is used basically to magnify the fluctuations that are happening and to make this very clearly visible. So that is one of the major objective, to magnify the fluctuations. Let us see how this is used. On the y-axis, if it is used, suppose this is various years, 2000, 2001, 2002, and this is say production in tons of certain item in a factory. So everything is between 800 and say 30 and 1000, 1050. So if you're taking 100 tons means 1 centimeter, so you're losing lot of space. So what I'm doing is I'm breaking the line and false baseline is being created here, right? So if you are taken 1 centimeter equal to 100 tons, then it would have been 100, 200, 300, 400, 500, 600, 700, 800 goes out of your graph paper itself, and you cannot draw it on your graph paper. So to avoid such things, from 0 I have cut a line here. This is one way of showing the kinked line, or else like how I had shown you, instead of showing this all things, this way it is shown. The line is cut here, then 0, then say 800, 900, 1000, 1100. This way you can show. So this also is possible. So kinked line or false baseline, here it is used on the y-axis, but not always on the y-axis. You can use it on x-axis also, like this way. So you can kink the x-axis as well. It's not that you have to kink only the y-axis. So this is one of the major usage of kinked line or the false baseline in statistics, that is especially in graphical representation of data. I hope you understood today's lecture. If you have any difficulties, you can always contact us.